This is one of the most surprising results in probability. It is called the birthday paradox. Imagine a room with just 23 people. Here is the question: what is the chance that at least 2 people in this room share the same birthday? At first, most people guess something small, maybe 10%, maybe 20%, maybe 25%. After all, there are 365 possible birthdays and only 23 people, so it feels like the chance should be low. But the real answer is much higher. It is about 50.7%. Yes, with only 23 people, the chance is already more than 50%. Now let's see why. If we try to calculate the probability of at least one shared birthday directly, it gets a little complicated. So we use the opposite idea. Instead of calculating the chance of a match, we calculate the chance of no match. That means no 2 people have the same birthday. Then we subtract that from 1. Now let's calculate the probability of no match. We ignore leap years, so there are 365 possible birthdays. For the first person, there is no restriction. They can have any birthday, so the probability is 365 over 365. For the second person, their birthday must be different from the first person's birthday, so they have 364 choices out of 365. For the third person, their birthday must be different from the first 2 birthdays, so they have 363 choices out of 365. And this pattern continues. Every new person must avoid all the birthdays that have already appeared. So the next terms are 362 over 365, then 361 over 365, and so on. For the 23rd person, there are 343 choices left out of 365. Now we multiply all of these probabilities. When we calculate this product, we get approximately 0.4927. That means the chance that nobody shares a birthday is about 49.27%. But that is not the answer we want. We want the opposite. We want the chance that at least 2 people do share a birthday. So we do 1 minus 0.4927, and that gives 0.5073. So the final answer is about 50.7%. That is the surprising part. With just 23 people, a shared birthday is already more likely than not. But why does this feel so strange? Because most people think about the wrong question. They imagine this question: what is the chance that someone has the same birthday as me? That is a much smaller question. It compares everyone to one fixed person. But the real question is different. The real question is, what is the chance that any 2 people share a birthday? Not necessarily with me, any 2 people. And this creates many more comparisons. Let's see this visually. Take 23 people. Person 1 can be paired with 22 other people. So person 1 gives us 22 possible pairs. Then person 2 can be paired with 21 new people. Person 3 can be paired with 20 new people. And this continues all the way down. Eventually we get 22 plus 21 plus 20, and so on, all the way down to 1. And this equals 253. So in a room of only 23 people, there are actually 253 possible pairs. That is the hidden reason behind the paradox. Even if each individual match seems unlikely, there are many chances for a match to happen. And as the group gets bigger, the probability rises very fast. With 23 people, the chance is about 50.7%. With 30 people, it is about 70.6%. With 50 people, it is about 97%. And with 75 people, it is more than 99.9%. So the paradox is not magic. The number of possible pairs grows very quickly. That is why only 23 people are enough. More comparisons means a higher chance of a match.